Hello everyone, my name is Bala Narasimhan. I am VP of Products at PernixData. Thank you for attending today's presentation titled Infrastructure Analytics. We'll be talking about the role of big data and analytics in designing and deploying your data center better. But before I jump into that, I just want to touch upon a quick story. This is a well-known story of the cobbler's children. And the story goes as follows, right? So there's this really good cobbler who works in a town, and everyone in the town wants him to make a pair of shoes for them. And so they all, come up to him and say, "Make me a new pair of shoes." And the cobbler obviously obliges. And this is what the cobbler does all day long. And as a result of which, he never makes a pair of shoes for his own children. So they walk around bare feet like that. And the question that I'm going to posit today is, as IT practitioners, are we like cobbler's children? In other words, right, we are deploying large databases and big data technology so that, say, marketing can run a better campaign and do product placement better, or we're doing this for manufacturing so that they can optimize the supply chain, or for finance because they can run that big report at the end of the quarter. But the question is, how much of these big data technologies, be it a large database deployment or a Hadoop or a Cassandra deployment, are we as IT practitioners using for data center design itself? And I would posit that we're not, right? And the question I'm asking is, why is that? Why is it that in 2016, as an IT practitioner who wants to make a design choice, I cannot ask a question such as, how are other people in the world who have a similar design requirement such as mine doing? And what can I learn from that? You cannot ask that question today because the data, not that the data is not there, it's just that it's not accessible, and you cannot run those kind of analytics at high speed, right? And so this is odd for me, because in my mind, the data center is the #1 use case for big data. So big data experts define big data along 4 dimensions. So there's volume, velocity, variety, and veracity. And I would posit that the data center is maybe #1 in all of those categories. In terms of volume, if you have a single application generating 1,000 IOs per second, which is not a lot, and you're collecting attributes about that IO, and you have 100 such applications, in a day you're collecting upwards of 100 gigabytes of data just for those 100 applications. And of course, there's so many other facets to the data center. And if you're collecting data about all of these, the volume of data is tremendous. The velocity of change is really high. We all know this, right? If you look at CPU consumption or memory consumption or storage latencies, it's never steady. It's up and down. There's a lot of change happening in the data that you're collecting in the data center. Data comes from multiple sources. If you have a virtualized data center, you're getting data from, say, vCenter. You're also getting data from your Linux deployment. You're getting data from your Windows deployment, from your Oracle database, from your SQL Server database, so on and so forth. And finally, veracity, right? So a colleague of mine, Pete Keeler, has written a really nice blog post about this, where if you're trying to understand memory consumption in your database, not in your database, in your server, for example, you can look at top within Linux, you can look at HTOP, you can look at active memory in vCenter. All 3 things are reporting something, and all 3 things are accurate, but they're not the same. And that's because they are accurate in the context in which they're reporting that. And so it's important to understand where that data is coming from. And so, like I said earlier, I believe that the data center is the #1 use case for big data, but it so happens that we're still stuck here. This is the world we live in, right? What you have in the data center today are a bunch of monitoring tools with red and green blinking lights. And if the red light goes on, we all need to scamper and figure this out. And then when it becomes green, we'll take a rest, and then we'll wait for the next red light to go on. And it's unfortunate. It's unfortunate that we are so reactive in the way we do things. The best we've done to date is, we'll detect a statistical anomaly and we'll move some VMs around. This is, state of the art in 2016, which is, hugely disappointing in my mind. But where we want to be is this, right? In the ideal state, you will be using data to design, deploy, operate, and optimize your data center. You will be having a tight loop around those so that there's a feedback loop going, and you're able to constantly do this, right? And not only that, with your data, you're able to predict when something bad's going to happen, or when some change is going to happen. that data is then prescribing an action to you, saying maybe you should do this in order to alleviate this potential problem, and it's making a bunch of recommendations to you. So we move away from a world that is only descriptive, so to speak, red lights go blinking and all of that, and we move towards a world that's also predictive and prescriptive. And big data will allow you to do that for the data center. So that all makes sense. So why are we not there, right? So clearly we are not there today. Why are we not there? There's a number of reasons for that. The first is that it's early stages. Obviously, a lot of these technologies are somewhat new, right? And we're still kind of learning how best to use them. To date, user experience has been an afterthought in a lot of the infrastructure products, right? And it's very important that you get the user experience right when you're talking about big data and analytics. It's very easy to simply throw a bunch of data in front of somebody and say, figure this out, right? But what's difficult is to show them the data in such a way that they're able to understand it, and like I said earlier, take actions because of that. And today, essentially what we're doing is pretty much an afterthought, right? We give people a dashboard with 100 reports on it, and we say, here's all your data, now figure this out. Or there's a red light blinking, figure this out, right? And finally, the form factor, right? Today's data center is very, or the analytics part of it at least, is very encapsulated inside the form factor in which you're deploying it. So if you buy a storage system, then you will get analytics about that storage system. If you buy a server, you might get analytics about that, right? But you don't get analytics across the data center, and everybody's views are different. So it's up to the end user then to somehow correlate all this data and make sense off of it. There's also a number of technical reasons why this is difficult. First and foremost being that, like I said earlier, there's just a ton of data that you're generating. How do you amass all this data? How do you integrate those various disparate data sets? And how do you drive the analytics at high speed? So there's a number of technical challenges that need to be solved, right? It is a real-time problem, because what's the point of making a recommendation 6 hours after the event occurred, right? And it's an ontological problem. And what that basically means is, you need to understand the semantics of how you're deploying the data center. Meaning that if you had, say, 2 servers, one with a particular make and model of say flash inside it or a CPU inside it, another one with another make and model, you can't generalize that. You have to. It's better to understand what that make and model is and why it's behaving the way it is, and then somehow extrapolate from that. So semantics matter a lot. So now what I'm going to talk about is, okay, so I've kind of made the case for why big data or the data center is the #1 use case for big data. I've talked about why we haven't quite gotten there yet. I've talked about the technical challenges that stand in our way, the non-technical challenges that stand in our way. But now what I'm going to say is, okay, let's say we decided we're going to actually solve this problem, right? We're going to solve this problem. What are the design principles that you need to incorporate in order to build a product that will help you solve this problem? So I'm going to propose 3 design principles. The first is, you need to understand data, right? You have to build a product that is able to do 2 things. It's able to generate its own data, because that's when it makes most sense. If you simply rely on third-party data, then you're only as good as that third-party data is, right? And you need the ability to generate your own data and integrate that with other data sets so that you can drive better inferences. So you have to get data. You have to be able to collect a lot of data at quick speed. You have to be able to interpret that, integrate that with other data sets, and drive rich analytics from there. The user experience is critical, right? I touched upon this earlier, but what do I mean by that, right? So like I said, if you simply throw up 100 reports in front of somebody and say, go figure this out, that's not a great user experience. You're simply intimidating the user. What you instead need to do is to provide data at various levels of granularity, right? So that if you give the most important and relevant data to the user, and then you provide them the ability to drill into the data as they see fit and to drill back up. So in analytics terms, this is called ad hoc analytics. You allow the user to, in ad hoc fashion, start at a top level. When they become curious about something, you allow them to drill down all the way to the most granular data and come back, roll back up, right? That allows the user to, if everything is going fine, they can see the data, interpret it correctly, but when they want to analyze something, they're able to do that. Don't throw esoteric terms in front of the user. So if you're familiar with Oracle, and I worked at Oracle for many years, the Aura 4031 is the error that the Oracle database throws when it runs out of memory. So let's say the database ran out of memory. You'll get a message saying 4031. What does that mean, right? And unless you've spent so many years diagnosing this database, you don't know what that means. But of course, after 5 years, you and your buddy talk about 4031s all over lunch, right? I had a 4031, you had a 4030, but it takes 5 years to get there. And so what will be nice is the experience like the TurboTax thing, right? There's the easy button. You click on the easy button. It makes sense. And if you want to drill in and you want to customize it, you can. And finally, let's get the computers to do more. This is what computers are good at. They're good at taking a lot of data, analyzing it, and driving inferences. Let's have the computer do more, right? And if you do that, then you can get away from this very descriptive world that I was talking about earlier, where you have the red blinking lights, and you can move toward that predictive and prescriptive world, where the computer looks at all the data. It is able to understand what's going on. It's able to make recommendations to you. It's able to prescribe things that you can do, right? And that's the right place to be in, because once you have so much volume of data and you have so many disparate data sets, it's impossible for a human to put it all together. So those, in my mind, are the 3 design principles you want to incorporate as you build such a product. And so this is what we did at PernixData. We released a product called Architect about 4 months ago. And we named it Architect for a reason, because we felt like it was a product that allows you to do just that. It allows you to design, deploy, operate, and optimize your data center. And I want to tell a quick story to kind of drive the thought process that went behind the genesis of this product, right? So we have a different product that helps with storage performance, and we focus a lot on user experience, and in my opinion, it has a great user experience. And I was talking to our end users about this product, and I would always ask them whether their performance is getting better because they deployed this product, and they would consistently come back to me and say, you know what, performance got better, but from your UI, I learned all these new things. And specifically, I had one customer who had a SQL Server database, and it was a long weekend, so no one was working, and everyone took off for the long weekend. And when this person came back to work, he noticed that for some odd reason, this SQL Server database was doing 1,000 odd IOPS anyway. But there was no one at work. It should not have been doing that. And he noticed that in our UI. And then he went and investigated that, and he found out that SQL Server VM was not configured correctly from a memory perspective, and so it was paging. And that was what was causing the IOs to happen. And this was in 2014. And for me, at least, it was amazing that in 2014, you had to rely on this UI to understand that your VM was shortchanged from a memory perspective, right? And it was experience such as that kind of got us to thinking that there was a need for such a product in the market. So just a quick rundown on some of the things that it does, right? Because I touched upon the need for predictive analytics and prescriptive analytics. So this is a screenshot of Architect talking about working sets. Why does this matter? Like, we talked about this in the earlier panel as well, right? You could have 200 petabytes of data in your database, but if only 200 gigabytes of that is what is important to operate your database, then that's the 200 gigabytes that you need to optimize for. But today, if you ask any application owner, what is that number that you need to optimize for? Most of them don't know, right? The working set computation is a computation of that number. And what Architect does is it looks at the application and it predicts what its working set is going to be. It predicts that for today, and it keeps changing over time as it's predicting how that working set is going to change. And so they're able to design your data center better because of that. Here's the ad hoc analytics I was talking about. You present the data to the user, at a high level, at an aggregated way. Now, if there's a particular spike in the graph, for example, that a user wants to investigate, they can drill down, go as granular as they want, and then roll back up. This is in contrast to the usual methodology that we have, where we present 100 reports to the user and say, figure this out. And finally, recommendations. So now this is prescriptive analytics, where the system is actually making recommendations to you about what to change in your data center based on what it's seeing. So when I started the presentation, I asked this question. I asked the question, right, in 2016, if you wanted to make a design choice in your data center, can you find out people similar to you who have similar design requests? What are they doing? You cannot today. But we think with this idea called PernixData Cloud, you can actually get there. So every Architect deployment in the world is now sending anonymized metadata to the PernixData cloud. From there, you can drive a bunch of insights, right? So now we can actually get to the world where if you have a design change you want to make in your data center, if you want to optimize your data center a particular way, you can find out how others are doing this, and you can follow those prescriptions as well. So I think these are the kinds of things that will eventually result in this feedback loop that I was talking about earlier. And this is really where data center management needs to go, right? So if we allow for predictive and prescriptive analytics in addition to just the pure descriptive world that we are in today, then we can actually get into this feedback loop. IT can become a lot more strategic because of this, and we can stop being as reactive as we are today. Questions? Yep.
Okay, so you started out talking about ontologies and semantic stuff. Can you tell me a little bit about more which semantic stuff magic is happening?
Yeah, so I mean, I'll generalize it, right? So for example, right, let's say you have two servers, right? One has a SATA controller on it and the other has a SAS controller on it. You can plug SSDs into each of them, right? But if you simply make an inference on performance based on that without the knowledge that this one has a SATA controller and this one has a SAS controller in it, the inferences that you're going to make are limited. Whereas if you understood the semantics or the ontology of what was going on there, it would make sense at some level that this one is has a throughput that's lesser than the other and so on and so forth. My point being that the semantics makes the data a lot richer because context is important for everything, right? So that's basically the point. Question?
In the beginning of the speech, you said something about like data is generated by itself. So what does that mean?
Right. So there's two ways in which you can design a big data product, an analytics product, right? The first way is to say, I'm going to rely on third-party data. There's a data set, right? I'm going to rely on that, and I'm going to give the end user analytics based on this third-party data set, okay? So if you build two analytics products like that, most probably they will be, the richness that you're going to get from that is limited because you're relying completely on third-party data, right? Whereas if you build an analytics product that not only relies on third-party data, but is able to generate its own data, and that goes back to the ontology thing I was talking about, right? Semantics and all of that, and you marry those two data sets together, you can drive much richer analytics because of that.
What size environment would you say would benefit from your product? 10 virtual servers, 100?
So that's a great question. A lot of people have asked me that question, and on the face of it, it would seem that something like this makes more sense in larger deployments, right? But what I've seen is that it is equally beneficial in both. It just happens that in the smaller environment, you have 3 applications that are problematic, and in the larger environment, you have 300 that are problematic, right? The key point being here that once you have those semantics that I was talking about, you're able to combine application-specific data with infrastructure data, right? And so then you're driving a very rich set of inferences you couldn't before. So it doesn't matter if you have 3 problematic VMs or 300, you're still able to drive that analytics with it.
What is a collection method for? You're getting the data. Do you use agents at the VM level or the application level?
Yeah, no, we do not use agents at all. Our product is a module that goes inside the hypervisor. So we do not use agents. You don't need to rewrite the application either.
And what about using other data visualization or analytics tools on top of that data that's collected? Or is it self-contained?
Yeah, today it's our UI that's rendering it, right? That's where we are today. But over time, I can envision a world where you can do that as well.
It's a web-based UI, right?
Correct.
So do you also allow to do analytics across, say, the cloud into the VMware cloud, across the vSAN devices?
No, today we do not allow for that.
Thank you.
Yep, thank you.